All right, how about now? Can you guys hear me now? I forgot to hit the go live button, but y'all should be able to see me, hear me, and all those nice things starting now. So do let me know, keep me posted if that is the case. So go ahead and get started for today's office hours. Put on an agenda here, create a Python script and version control with Git. So that's the agenda, of course. We'll be taking other things people want to throw on the board. But the whole point here is now that we're wrapped up the mini projects. If I go back, we did finish up we did finish up working on Q6. So what I want to do next is, how about we take what we've done in this notebook and package it together into a couple Python files. That is our goal for today, and perhaps tomorrow as we get in as sort of a good project zero before we go on and work on something a little bit more elaborate, something a little more with some additional skills. So that is the plan. Let's see. I see Anna is here. Hello, Anna. No need to apologize. Make sure, but glad you're back this week for office hours. And keep in mind that we do keep a playlist of past office hours, so please look at that playlist if you want to revisit past topics. All right, I see Tom is here. Thank you, Tom, for that confirmation. I see that Shakiba is here. Hello, Shakiba. Hello, Naye. Lyndon Smith, thank you for the confirmation. Hello, Esther. Hello, Emmanuel. Welcome to WorldQuant Office Hours. I see that Shubham is here. Welcome, guys, to Office Hours. This is the agenda, of course. Throw anything additional questions you'd like me to address and answer for Office Hours. But this is a plan. Let's go ahead and take what we've created in this notebook and let's package it together. The whole point what I'm trying to illustrate is how we can reproduce our data analysis. You can think of the whole point of this mini project while it was to complete it, right? The whole point here is to imagine a situation in which you are able to take these prescription data and data about these practices for every year and do some data analysis to flag maybe some suspicious practices, some suspicious drugs. Not saying those people are overprescribing opioids. Maybe there's a valid reason why their opioid prescription rate is rather high, but you can think of this as our analysis so we can further investigate, maybe in some sort of internal audit, make sure everything is going fine. That sort of was the motivation, sort of the business case, the objective when we do data science, right? We do data science. There's always some objective, some motivation. You could think that is our motivation. So that's what we're going to do today. But we're also going to practice working with Git, the whole idea of Git, because we're going to use it for our other project as we move forward. I see Paulo is here and Gita. Hello, people. Welcome to Office Hours. So I want to talk a little bit about version control. So when you work on a project by yourself, it can be very easy for you not to implement some sort of mechanism that keeps track of the project's evolution. The projects change with time because it's just you, right? It's just you. You know what you do. You know those acronyms you use, those shorthands. You know your coding style. However, one of the core principles I've been addressing throughout office hours is the idea of readable code. The idea that code is more often read than written. Someone's asking about Azure DevOps versus GitHub. I can put a little note on that. Azure DevOps versus GitHub. All right. Yeah, code is more often read than written, so we got to make sure that the code we write is readable, because readable code is also more maintainable. Very rarely code is static. There's always some situation you have to update your code, fix certain bugs. So code is very rarely static. You add new features, you improve on it. So it makes sense that if we have our code that's readable, then it's easy to maintain. And while even easy to read and maintain, not for other developers, but our future selves. So even though you don't care about anyone else, hopefully you care about your future self. And one of these efforts to keep track of a code base, so when I use code base, I'm referring to all the code and all the files related to some specific project. That's what I mean by code base. when you work on a code base, it'd be very nice if we have a track, some sort of history of the evolution of the project. Think of it as a history book or a log book. We're able to open up and see how the project has evolved. See a log book where you add entries. Every time you make some sort of change to the code base, you write an entry saying, this is what I changed. This is what I changed. I added this feature. I added this feature. I fixed this bug. I added this feature. I made this simpler. I allowed this script to work for this special case. It's very nice if I can have a history book, a log book of the project's evolution. And the reason why this is great is because if you're new to the code base or someone is new, they're able to look at that log and see what has happened. Right? It's very difficult to go through all the code, all the files, but it'd be very nice if I can look at a log book. Very easy if I can go through a log book and see the evolution of the project. And the other reason why this is on, so it'd be very nice to have some sort of system, what's called version control. Version control. Version control. And the reason why it's called version control is because at certain points in this history book, I can call it, this is this version of the project. That is this version of the project. So for example, if each of these dots represents an entry into the logbook. So maybe I added this file. I added this feature. I fixed this bug. Then what I can do is when I release my product, maybe this is a product that I released to the general public or maybe for internal use in the company, I can say all the changes up to this point here. You can think of this as time. This is the arrow of time. I can say, okay, everything here is a certain version of the project. The other advantage of this system of recording changes into my program is that if some later time in history I add a bug, I add something to the code base that makes it break, and maybe I don't realize that I made it break right away, but I add something that makes it break. What I could do is I can look at the history and I can easily look up what was the change caused by this set of changes. Each of these dots you can think of as a packaged set of changes, a discrete set of changes that I've called a commit. And why I call it a commit? Because I commit those changes into history. Well, this is a little bit abstract, I understand, but we're going to actually work with Git so you can maybe, those what it means by Git commit. Those what it means by a set of changes that we package together. We'll go ahead and do that. But let's say I introduce some sort of change here that messes things up. I can always go back and very easily with version control identify what was that change. And I can easily revert the changes caused by this commit in history. So I have this idea of being able to track the evolution of the project, understand the changes, understand the differences, be able to easily identify when bugs were introduced and remove those bugs. I am also able to, with version control, be able to easily work on a project across multiple people. Very rarely, right? If you work in a company, you're not going to be the only one working on a certain project. You might have collaborators, and everyone has to work on a set of files, a code base for a project. So this can be a little bit complicated, and I'm not sure about you, but I've been guilty in my younger years of working in a group project with people. Didn't have to do with anything programming or anything like that. Just a generic group project growing up in school, where the way we tracked, we had to work on the files together, and things have gotten better, of course. And we were just emailing or passing files back to each other. And we'd always name things like version 1, version 2, and then they may have a slightly different version. And we always have this weird naming scheme and passing files around, and it wasn't always clear that the file that I was working on was the one that was most up to date. So let's say we have a better system for collaboration. And let's say we have, and I'm going to draw this out, but I'm going to take a look at the chat because I see some activity here. I see someone is having issues with their pod. Probably means that there is a surge of a lot of people using the pod right now. That could be the issue. Let's see. But if you let Basa Waraj, if you let me know your username, I can take a look at it after office hours, and just make sure everything is going fine. I can take a poke at it, make sure everything is going fine. Maybe it's just to make sure it's not something else, and if it's maybe it's just a surge issue. All right. I see Kinjal is here. I have a question regarding the script anomalies and Z-score. Kinja, do let me know your question in the chat, and I will take a look at it. All right. Yeah, and I mean, we have a very large class. We have to serve a lot of students, so sometimes things are a bit slow. So I do appreciate your patience with that. But do let me know your username so I can go ahead and we can go ahead and fix that issue. Kinjal, I see your question, so I will get to it when I get to a certain pivot point. So so thank you for posting your question in the chat. And let's talk about collaboration. Let's say this is me, and this is maybe you, and this is maybe someone else. And I want to be able to collaborate across this code base very easily. And every person has the code on their personal computer. They have the set of files on their personal computer. However, the changes that I make, you're not going to necessarily see, because those are changes that only exist on my personal computer. So what if instead we had a system where there is this central repository, this remote repository, where the code exists. And this here represents the official version of the code. So what I do is I clone this code to my personal computer. I see your username. Thank you. I'll take a look at that right after office hours. Let me take a note of that. So what I'm going to do is I'm going to clone the official repository. And I clone it to my personal computer, and what I'm going to do is I'm going to make changes to the code base. And once I make those changes, what I'm going to do is I'm going to submit those set of changes for request to be merged into the code base. Think of it as I take the code, I propose a set of changes, and I go back and I say, hey, these are my proposed changes. And then what will happen is other people can approve of those set of changes. And if they approve of those set of changes, then they can be merged into the official code base so that other people can clone or update, pull in those changes to their personal copy and have the changes that have been merged in. So in other ways, you can think of the model we can work with collaborating across is we're going to propose changes to the code base. Those get approved. By approved, they get merged into the official copy. And then other people can pull in those additional changes. So now I don't have to pass around copies of some changes across my collaborators. It's all located in a central repository, a single source of truth. You'll hear this thrown around a lot, specifically with data, this idea of if you have a single source of truth, then you don't have any issues of, oh wait, That's that version, and that's that value. What is a true one? What is the actual source of truth? Well, there's only one single source of truth, and that is this central repository. So that's the whole idea of version control. Of course, we're going to go ahead and try it out. One of the things we want to learn, right? One of the things we want to practice with. So with that said, do let me know if you have any questions right now about version control before we dive into taking what we've written in our mini project and create a script. Perhaps use argsparse. I know someone brought up that topic. We want to talk about argsparse and go ahead and play around with Git. All right, let me take a look at the chat. I see Kinjal has a question. In the first, usually it's recommended that all data should be within -3 to +3 z-score, and that's typically, yeah, yes and no. All right, it depends. You typically see 2. Typically for the z-scores, you say anywhere from 2, -2 to +2, because I believe this is 95% of your values. But if you want something stricter, you can use -3 to 3, which I think is 99.7. And it's really all about your tolerance. How many of those suspicious values you want to identify. If you use -2 to 2, that's 5%. That could be a lot. -3 to 3, it's to be a lot less, but maybe that you don't want too many. So typically you see -2 to 2, -3 to 3, something like that. It depends on the nature of the application. You have a follow-up here. Is the first 100 of the results. So we have results where the z-score is within those scores. Are they still considered anomalous? If they're within the cutoff, we're not going to call them anomalous. In fact, that's one of the things I want to do with this project. The first project 0 is what I'm calling it, because it's sort of like a precursor before we work on Flask. It's been a little more elaborate. Is the idea of actually applying some sort of z-score cutoff to identify these anomalous values. We don't do that for the mini project because we just say, give me the top 100, regardless of what the z-score is. But let's actually implement that in this project here. So we'll go and I think that will, what we're going to work on here is a little more centered around actually what you would do, because for the mini project, it's a little more geared towards doing something that we can get actually evaluated by the grader. So that's what we say, give us a top 100. And that's not necessarily what you would do in business. Yes, we're assuming the data is normally distributed. All right, is it better to clone the code than download the code? It is better to clone the code because, well, what it means to clone is, and I'm going to try to be very specific in my language, is cloning refers to not only having the code, the files of the code, but it also means having the history of the project. And that's what you need. You just don't need the files, you'll need the history of those files. So when we say clone, when I say clone, what I mean is the files plus history. Because if you have the history, you can also propose a set of changes. And if you just simply download the files, you don't have the history. If you just simply download the files, or if someone says, here are the files, you don't have the history that comes with that project. And if you don't have the history, there is no mechanism for you to contribute to the project. Someone is asking, what if 2 people are working on the same code at the same time? Well, then becomes an issue of you submit your proposed changes to the central repository. Then there is a set of people, maybe your collaborators, who have to approve of those changes. So imagine if there are 2 competing changes. First of all, ideally you'd be able to communicate with your collaborators saying, hey, I am working on this aspect here. I am working on this issue. So that there's no problem where 2 people are working on the same fix, on the same problem, the same feature, right? The first thing is communication, right? If you, better communication solves issues. But let's say that we poorly communicated with our collaborators, and I'm working on the same set of changes that you're working on the same set of changes, or we're working on two set of changes that affect the same part of the code. When we submit the changes, they have to be approved. And it might be that the people who are refereeing, who are maintaining the repo, who are their sole, not their sole job, but one of their job is to approve of changes, they might approve one over the other. So if I approve one over the other, then what I get is a conflict. What I get is a merge conflict. And the tool, your version control tool, should tell you that your change now has a conflict of what is currently in the code base. And it does help you, it does tell you where are those conflictions for you to fix. So there are mechanisms for that. The whole point here is that the fact that we have a central repository makes the collaboration a lot easier. I'm trying to find my water bottle. Where did I put my water bottle? Here it is. All right, do let me know if there are any questions. I'm going to open up a new notebook. I'm going to call this data analysis. I'll call it drug data analysis. How about that? Drug data analysis. And what I'm going to do is I'm going to go ahead and copy some of the code that we wrote. And what I want is, I'll put here, I want to have a set of files and a set of functions to flag certain practices that are perhaps over prescribing drugs. And right, the whole point here is innocent until proven guilty, right? Whole point is say, hey, maybe some little fishy, not say that they are in fact violating, just maybe pull more attention there. Okay, I see someone saying, can't understand the concept of OOP in plotting. Can you add it to the agenda? All right, I can add that to the agenda. Object-oriented programming with respect to plotting. Yeah, I can talk about that maybe later on this week. See, Naya says, I think when you do git add or git commit, you are going to see the changes from the team in the code. You're able to see the changes of the team from the code once you pull those in. Right? In fact, we can see that's where the git log comes into play. We'll practice with git, by the way. I know this thing was a little bit abstract, and we'll actually see some of the things when we get to it. But to work with git, we got to have code to work with git, right? So that's what we're going to build up here. So we're going to have, I want to have a set of functions to flag certain practices that perhaps are overprescribing drugs. And what I'm going to go right here is, what do we need? What do we need? All right, so someone says, can you break down the code written in the stats notebook for the true mean? All right. Stats notebook, true mean. All right, put that on the agenda. All right, so what do we need? Well, we need data. So we need prescription data and practice data. We need a function that calculates the z-score of the opioid prescription rate. In other words, we need a basically what we did in, I think, Q5, right? I think it was Q5 or Q4, the code that finds a z-score for each of the practices. And then what we need is we need a z-score cutoff. We'll need a z-score cutoff. In other words, we need a way to say, hey, if you have a z-score greater than this value, you are suspicious. And then finally, once we work on here, we are going to implement this as a command line script using argsparse. That's the outline of our agenda here. And we're going to first do this in the notebook because the nice thing about notebooks is that they're interactive. They're interactive, we get instant feedback, they're very nice, and then we'll transfer over to a Python file. Okay, so if I go here, and it's going to be a little bit messy because I have to find where things are, but here are some things where I import the scripts, and let's see this right here. I'm just going to copy a lot of this and we're going to organize it, because one of the things we want to get practice with is having code that is well organized, because well organized is maintainable and readable. And I feel like sound like a broken record. I keep on saying this whole idea of maintainable and readable, but hopefully you guys are in agreement with me, or finally say, yeah, he's got a point, right? Code should be maintainable and readable, right? And if you don't care about anyone else, right, hopefully you at least care about your future self. So here I have this code. And let's see what else. Found the opioids. Oh, I think this was one where I got the wrong answer and I got frustrated and I was like, okay, let me go and start from scratch. That's what that one. Yeah, I remember that's what happened there. That's what happened there. It happens. That's what happens. When things are a little bit messy and you're doing things to show points and whatnot, you lose track of state. So here I am just copy and pasting what I had. Standard error per practice. All right, I see a couple other things coming in the chat, so I will take a look at that once I finish copying everything. Okay, I think that's it. I think that's most of it. We're of course going to clean things up, and we're going to clean things up not only to be more readable, but to organize our code into functions. I'm going to take a look at the chat going on here. Could you also break down, let's see, would you suggest working on this on PyCharm or VS Code or similar for code to be pushed in GitHub? Yes, I really do recommend that when you work on these projects, you do work with a some sort of text editor, integrated development environment of your choice. It's up to you which one you choose. I know a lot of people like VS Code and Atom and Sublime are popular ones. So what I suggest generally about text editors and IDEs is learn one pretty well and make sure the one you learn can be used for other programming languages. So for example, VS Code can be used not just for Python, but for basically any other programming language. I've played around with VS Code a little bit and I do like it, just from what I've seen. PyCharm, I've never used PyCharm. The problem with that I have there, just with the name, is I'm a little concerned it's too much specific for Python. So if you work on another programming language, you'll have to use a different tool. So yes, I do recommend something like that. Of course, we only have limited resources here in the pod, so we'll do things a little janky. But later on, towards the end of the course, I'll have to show you my text editor because we'll be doing things sort of on my personal computer. Also to break the code into Jupyter Notebook when they get long. I tried by just using to enter break and give it my indentation errors. Should we set up the repo in GitHub and clone it before writing the code if starting the new project, or getting it local drive? All the yeah, let's going to Raw Garage questions. We would first focus on getting it on our personal computer before we push to GitHub. So yeah, that's what I prefer to do. I like to first get it organized, working on your local machine before we push it to a central repository. And something like GitHub provides that central repository. I tried, but using the enter break and gave me indentation errors. Yeah, indentation errors can be a little tricky, so we're going to kind of clean up this code here. Yeah, right. You care about yourself. Tom is asking about Spider. I think Spider is another one of those IDEs that are Python specific. I guess there are more than things. I think, yeah. I mean, the nice thing about Spider is because you can have your code and these plots, which are very nice. But my concern is that it's just for Python. I could be wrong. And it's be very great. Maybe later on in the future, you won't be working with Python. Maybe you're working with Python and something else. So it'd be very nice if you learn one text editor or one integrated development environment that works across other operating systems. That is my opinion. I really will leave it up to you to choose what is best for you. But my advice is learn something that's more general purpose. All right, so I have copied all this code here. It's a little bit messy. Oops, right there. So you can think of really our breakdown for this question is load the data, right? The steps. Sometimes it helps to break down the steps, right? Steps are to load the data, load and clean the data, right? Load and clean the data. And then we flag the opioids, and then perform the merges and analysis, the data analysis. And the final broad step is sort, right? Sort and find those that are suspicious. Generally, the broad strokes of this question is load and clean the data, flag the opioids, merge, do the z-score analysis, and then sort and find those that are suspicious. And the reason why it's important to break it down into steps is because you can view these steps as ways to package the code, ways to be able to discretize our code. Someone is asking which week is this code for? This is for the DW mini project. We're taking one of the questions, and we're going to go ahead and create a Python script to analyze, flag those suspicious prescriptions. So the reason why I broke this down is because we could have a function called load, something called load and clean data. All right, have a function that's going to go ahead and load and clean the data, so we can know what's know that's the case. So maybe something like scripts and practices. What are the couple of things we do? Practices. And the other one is the chem data set. I don't think I forgot to copy it over. Right. Load and clean data. And here we're going to put a doc string. In other words, a string at the very top of the function that tells it what to do. And this here is, it's a little bit, if we write good function names, the function says itself. But of course, we can say returns scripts, practices, and chemical data sets. Returns the cleaned scripts, practices, and chemical data set. So right, the function has a very clear name, loading clean data. What does it exactly do? It returns the clean scripts, practices, and chemical data sets. So we'll go ahead and do that right there. I'm just going to break it down. It's a little more easier to read in my opinion. And I'm going to put a note here that's saying need to drop duplicate chem sub rows. Just a little reminder, remember we'll flesh it out. And this is return scripts, practices, and chem. All right, so now I define this function. Perhaps I can. Next thing on my list is flag the opioids. Flag the opioids. So I'm going to have a function here. It says flag opioids. So it's very clear when I read this. I know what it does, and it accepts the chem data set. And it has these opioids right here. And let's see right there. And I think I see a question that Kinjal is asking, that why does the is-in not give the same results as str contains? Good question. I believe it should, but now I'm thinking about it. Let me think about that. Pandas, data frame, pandas series is in. Let me just refresh my memory of what the is in. Whether elements in a series are contained in values. So in other words, if we have a series of llama, cow, llama, beetle, llama, hippo, so the reason why is contained, I don't think is going to work out for that question, is because our drug names are rather long. And we are basically looking, what we're doing for that question is we have this very long name, blah, 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 methadone, blah, blah, blah. And we want to know if anywhere in this long string contains one of the strings we flag as an opioid. If we said instead is in, and we give is in, we give it a iterable like methadone and codeine and cocaine. I guess maybe not. I don't know. Don't even know if cocaine is prescribed, but oh well. Is in would say, hey, is in this long string? Is any of these? Is this long string in these individual strings? And the answer is no, because this is a long string. So this long string isn't one of these. We want to ask a slightly different question. Do these individual strings exist in this long string? And that is why is in is going to work out. All right, we can see this example here. We're checking if literally llama is in either this iterable, which contains cow or llama. All right, we're going to flag. So let me know if that answers your questions. We're going to flag opioids. And what we're going to do here is, it's a little subtle, but I'm going to copy the data frame that comes in. And this here creates a separate copy, so it's not going to modify the original. And I do this just in case I don't want to modify the original. I modify a copy. And I have here, it says add column to data frame flagging prescription if it's an opioid. So that's what I do there. I package it to a function. Next thing I do is perform the merges, right? Perform the merges and data analysis. So let's go ahead and do that. And I'm going to have here is, I'm going to call this, really it's going to calculate the z-score. So why not have a function that says calculate the z-score? Let me go ahead and get that there. And sometimes it helps that I have the code first and then I say, okay, what are the arguments of the function? Scripts and chem, so I do the merge. And then what else do I do is, well, I did that all that right there. Did that all right there. I did the merge. Fill in the missing values. Fill in A as false. And then did the whole group by business here. Opioids per practice, group by, calculate the mean. Relatives per practice. Let me go ahead and paste that there. Relative opioids per practice. And what else? Standard error. And then finally, did I copy? Opioid scores. And finally, I have the opioid scores. So that's what I do. So this is going to accept scripts. Scripts and chem. Anything else I need as my argument? Scripts, chem. I think everything is fine. Opioids per practice, relative, and calculate the z-score. And then what I should do next is I should return, right? What I do is I calculate the opioid score, and then what is next is I do the whole add that z-score to the practices. So this here is going to return a series. Return opioid score. And I have here as my doc string, return the z-score for each practice. Return a series of the z-score, right? We want the doc string that when people read it, we know exactly what gets returned when we use it. Exactly, it contains and is not in, right? Because that long string isn't exactly one of the elements of the iterable that is passed using is_in. Okay, return a series of z-scores for each practice. I think that does it there. It's a little, and I'm going to put a little, here is the merging part, and here is the, calculate z-score, right? The actual calculate the z-score for each practice, or something like that. Just put a little bit documentation there. All right, so hopefully by now, our code is looking a lot nicer. Load and clean the data, flag the opioids, calculate the z-score. And the next thing we do is the actual, this part here where we take the practices, we add the z-score column, and we do the sorting. So here I'm going to call this function flag anomalous. I don't know how to spell anomalous. Flag anomalous practices. So unique practices. So this is going to accept practices. And z-score. So our opioid score is what I call it. Opioid score. And what else? Sort values. Right, and I can say, and I'm going to give it a z-score cutoff. to say cutoff of, let's say, 2. So in other words, this is the thing where we're going to deviate from the mini project. The mini project says, give me the top 100, even if those top 100s aren't necessarily anomalous. What I want to do instead is do a z-score cutoff. In other words, give me the ones that have a z-score greater than 2. I don't, top 100, who cares, right? Because maybe half of those are fine. I'm going to do it by a cutoff. And I want to provide in this function here, the user can select what should be that cutoff. So what I can do, so this is right, drop the duplicates, unique, set the index at the opioid score, unique practices, and I'm going to call this, what did I call this? I'm going to call this result. Then I can say result, and I'm going to say z-score. I'm going to look for the z-score that are greater than the z-score cutoff. In fact, I can do a query, right? I can say result query and say z-score greater than, it's called z-score, greater than, what is the z-score cutoff? And this here, ampersand, means to use the value of the z-score cutoff. And return. I think that works out. So let me know if you have any questions of what we've done, but notice how I broke it down into a set of functions. And I'm going to go ahead and start, I'm going to just comment this stuff out, just in case I need it. Just in case I need it. In the meantime, let me know if there are any questions, but I'm going to comment this code out because I'm not going to make use of it anymore, because I've packaged it into functions, which hopefully now leads to a more readable solution. Looks like I ran it by accident. Flag. I'm just running things by accident. Shift is too close to enter. That's what's the problem. Okay. So now I have it. And I'm going to say kernel restart clear output and cell run all. And I have an error, so let's see what that error is. No. There is no error. So I don't know what happened there. Run all. There you go. That worked out. Okay. So I ran all the cells, but nothing has happened yet because I've just defined functions and nothing has happened. Well, nothing has happened because I need to next call the functions. So you can think that what I do next is I'm going to load the data, right? I say this here returns scripts, practices, and chem. So I can say equals load and clean data. What follows next, the next thing I gotta do is flag the opioids. And I say chem equals flag opioids and give it the chem data set. What comes next is calculate the z-score. Say opioid scores is pass it the calculate z-score function. And what does that function wants? It wants the scripts and the chem. Scripts and chem. And then finally what is next is flag anomalous practices. Flag anomalous practices, and I pass it practices opioid score, and I can say a z-score cutoff. So I can say a z-score cutoff of 3. I'm going to call this anomalous practices. So notice now that hopefully I have something that is more readable. Because if someone wants to know what is happening with this file, they can open up this file. We're going to put it into a Python file later on. They see all these functions. And I'm going to put here is a return practices that have a z-score greater than the cutoff. I see all these functions, which tell me, the functions tell me how it is accomplished, but this block of code here tells me what happened. And the whole point here is sometimes I'm more concerned about what it does as opposed to how it does it. If I want to look at a code, the first thing I want to ask myself is, what is it doing? And then ask myself, okay, how does it do it? So I look at this, I says, okay, what this file does, it loads and cleans data, then apparently it flags the opioids, it calculates the z-score, and then it flags anomalous practices. If I am curious to see, well, how is it exactly calculating the z-score, then I can go and look at that function. So notice how it's sort of set up. Very broad picture, very big picture, which is fine because maybe I don't really care about the details. The details aren't in front of me that are blocking my view, so to speak. I see, okay, what does it do? Okay, that's pretty readable. That's what it does. Maybe I'm interested in seeing how it's flagging opioids. Then I can look at the appropriate functions. Oh, okay, that's how it's flagging opioids. So now let's go ahead and run this, and hopefully there's no errors. And there's a name error because, well, I forgot about importing pandas, right? So at the very top, I should do the imports. And import pandas as PDE. Let's run that. And let's run this again. I got a name error. Scripts with chem is not defined. Let's see. Flag anomalous. Let's see. Scripts with chem. And that's because I got to pass it. So I say scripts with chem. Let's see. I think I just really care about scripts. I don't need to have scripts with chem, so to speak. I can just say that right there. So practices, scripts, and opioid score. Practices, scripts. Let's see. Hopefully that runs now. Do let me know if there are any questions. And I get a name error. So it's got multiple values for argument z-score cutoff. So I forgot to run that, right? I do this mistake a lot with Jupyter Notebook. You make a change, but you forget to run the cell. All right, so let's try that. Let's try that now. That should work out. Data frame has no attribute values count. All right, so let's see. Scripts. It should be scripts. Let's see. What was it? BNF name? Well, let's see. Values. What did I want? I don't really care about count for this one here. Well, let's still do it just in case I want to. Okay, I'll make a note of that. We'll make use of that later. Count. We wanted to figure out how many prescriptions are for each practice. So it's practice. Let's run that there. Hopefully this finally runs. Key error Z. Doesn't know what Z is. It's happening. I know what's happening. I'm going to call this Z underscore. I think it's a problem with the query interpretation of that string. It thinks it's doing a subtraction. And let's see. Just rename that. Run that cell. And that ran. All right. Okay. So notice I have 30 practices that had a z-score greater than 3. So these are the practices that I need to be a little bit more suspicious on, right? All right. Any questions with people? Any questions people have of what I've done so far? So to recap is we put this all into Python functions. Python functions, and this is sort of our main part of the code. And notice what I can do is, since I let this become an argument, the z-score cutoff, maybe I want something that is less strict. Maybe I want a z-score cutoff of 2. And I can just change it there and rerun. And now I have more things that I flagged because I changed my z-score cutoff. I have 74 practices that I've been flagged as suspicious. We're going to go ahead and next is we're going to go ahead and put this into a Python file. We're happy with this because we want to run this in our command line. So we're going to open up here. We're going to say text file. And this is where if we're working with something like VS Code or Spider, it'd be a lot easier. But here we're just going to copy and paste this code into a Python file. And the whole point here is now we're going to go ahead and do some version control. And let me go ahead and rename this and call it drug data analysis.py. So it understands it's a Python file, so then it does the nice formatting. And that's what I'm doing right there. And I'm going to put this in this if dunder name dunder is equal to dunder main dunder. We talked about this. And it sort of makes sense that we use it here because we have our script, the 4 functions, and then we have this main part. Someone is saying, would it be drier to load the data as global variables? Would it be better? I think it would be better. It'd be nicer because notice these functions have a lot of arguments, practices, scripts. But the nice thing about having them as variables to functions is that I can do things like make a copy and modify the copy instead. So I would say, and right here, notice we passed 3 arguments back. That's kind of a little bit annoying. So I think, let's see. To answer your question is, yeah, it might be a bit drier. And this is where it's a trade-off, and sometimes there really is no right or wrong answer. So I would say I think it might be okay with having those files as global variables. I didn't do it this way, but it might be a little bit dry. I can see I can see the advantages there. I think this is where it's going to be a bit subjective what your preference is. But yeah, that's a good point. So we are out of time. So what we're going to do to pick up tomorrow is we're going to use version control to have this file tracked. So we're going to learn about Git. We're going to talk about ways to improve this. And then we're going to go ahead and make this into an actual true command line script using the argparse. So that is the agenda as we do this here. And then that's going to give us the foundation when we go on and start talking about web applications, Flask and web applications. So I like this because it's sort of introduced sort of a great way to transition from the mini projects to a project, something that we actually might do in practice. Get some more familiar with some of the Python tools, get familiar with Git and version control. So a lot to learn, a lot to still talk about. So hopefully you guys are excited. Of course, I will make a note of these couple of things on the agenda. I think I'll look at the stats notebook true mean and talk a little bit about object-oriented programming with respect to plotting. Because maybe in our project that we work together, we might have to do some plotting, right? So that said, guys, we're over in time. With that said, take care, guys. See you tomorrow and have a good rest of your day.